This is the homework help video for worksheet 8-1, and we're going to look at problems 9, 10, and 11. The directions state, graph each logarithmic function. Show the vertical asymptote and 2 points. Starting out, let's go ahead here with y equals log base 4 of x. So we're going to take it. Let's just make our little table with our 3 points like we did earlier in the year. So remember, there's always those 3 points that come into play. When our exponentials had a horizontal asymptote, our log functions always had a vertical asymptote. And for our parent functions, right, because this one has not been shifted around at all, right, we're going to have at 0 a vertical asymptote. We know that it's always going to cross through that point 1, 0. And then we're always going to have a point at whatever the base is for our x value. It will have a y value or an output of 1. So if we take this and we plot those points, we're going to say, all right, at 0 for x, right, we have that vertical asymptote. We should have a point at 1, 0, and then a point at 4, 1. And then we'll just draw it in, right? So it runs right along our asymptote, and then it curves up and out this direction. And now we can use that from number 9 to help us with number 10. Number 10 says y equals log base 4 of x, and now we're going to subtract 1. So if we just think about our parent graph table and how this will change with this function, right? Nothing's happening to x, so we'll just keep our same x coordinates. We're going to have 0, 1, and 4. But this one's being shifted down 1, so each of our y values is going to decrease by 1. So that's not really going to matter with our vertical asymptote, because since we haven't shifted left or right, it's going to be in the same spot. But now instead of being at the point 1, 0, we're going to be at 0 minus 1 would be negative 1. And then for 4, instead of being at the point 4, 1, we'll take 1 and subtract 1 and get 0. So this is the table I would use to help graph this one. So let's take it, and again, our vertical asymptote where x equals 0. We have a point at 1, negative 1, and then we have a point at 4, 0. And we'll just take it and draw it in. Then on to number 11. Number 11, we have y equals log base 4 of the quantity x minus 1. With this one, now we're going to be affecting our x values, right? So when we subtract 1 from an x, it's like we're shifting it to the right one. So as we create our tables, right, instead of being x minus, remember we need to do like the inverse of what's happening. So this would be like an x plus 1, and then our y's will remain the same as our original. So if you want to go ahead and put in your y's, we know that that's going to be a vertical asymptote. Remember, you're looking at this table over here, not the problem number 10. Go from problem 9. So vertical asymptote, 0 and 1. And then when we do our x coordinates, our first one, right, 0 plus 1 gives us 1. 1 plus 1 gives us 2. And 4 plus 1 gives us 5. We'll draw in what we need here. So we'll put in our vertical asymptote where x equals 1. We have a point at 2, 0 and a point at 5, 1. And then we'll draw it in. So just a nice little refresher on how to graph logarithmic functions that have been transformed. If you have questions about these, please make sure you reach out and let me know. Otherwise, thanks for watching.